This is Catherine Nightingale of Chattanooga State Community College. This video is for Linear Algebra WebWork Section 1.7 Problem 6. We are given two vectors v1 and v2 and a third one y, and asked for what value of h is y in the plane spanned by v1 and v2. Now recall from sections 1.3 and 1.4 that y is in the span of v1 and v2 if it can be written as a linear combination of v1 and v2. Now this means that x1 and x2 would have to exist so that x1 times v1 plus x2 times v2 equals the vector y. So our goal is to see if there is a solution to this system or not. If there is a solution, then y is in the span of v1 and v2. If there's no solution, then y is not in the span of v1 and v2. We'll start by putting them in an augmented matrix, and we want to row reduce. Now, row 1 is all divisible by 4, so I'm going to start by dividing row 1 by 4 and getting my new row 1 of 1, 2, 5. Now I want to start zeroing out the entries in column 1 underneath the leading 1. So I'm going to start with this 5, and I'll do negative 5 row 1 plus row 2 equals the new row 2. So we get the new row 2 of 0, negative 2, negative 6. Now I want to zero out this 2, and so I'll do negative 2 row 1 plus row 3 equals the new row 3. And my new matrix becomes the new row 3 of 0, 1, h minus 10. Now I'm going to use the same trick on row 2 that I did on row 1 to start with. I'm going to divide by a negative 2 so that I get a leading entry of 1. So I'll do row 2 times negative 1/2 equals the new row 2. So my new row 2 is 0, 1, 3. And now my final step is to zero out this 1 that's below the leading entry in row 2. So I will do negative row 2 plus row 3 equals the new row 3. And I have my final row echelon form matrix. 1, 2, 5, 0, 1, 3, 0, 0, h minus 13. Now, recall we're trying to have a consistent system so that y will be in the span of v1 and v2. So that happens only when the h minus 13 is equal to 0. So the system x1 v1 plus x2 v2 equals y is only consistent if h minus 13 equals 0. Otherwise, we would get a contradiction in row 3 of 0 on the left and a non-zero on the right side of the equals sign, which is not possible for a consistent system. So we're left with h equals to 13 makes the system consistent. So y is in the plane spanned by v1 and v2 when h equals 13. Now let me show you one alternate method, which is really just solving it by inspection. So we have our system. We have v1 plus something times v2 equals y, and I want to find the weights, the something for v1 and the something for v2. Now, I'm going to focus only on the top two rows and try to see if I can come up with a combination. So, just looking at it, I try to find a numeric combination of weights that will work, and I get negative 1 times the 4, 5 plus 3 times the 8, 8 gives me the 2019. So from there, what I'll do is I'll figure out the h by applying those weights to the third row. So I'll do negative 1 times 2 plus 3 times 5 equals h. So that tells me negative 2 plus 15 equals h. So h equals 13, which is and should be the same solution as reducing the matrix. So either method works. Inspection saves time if it's an easy one to see, but they're not always easy. And so row reducing is your method that will always work.